Now we will continue one more video. Electronic conductors. What is electronic conductor? It is a material or substance which can allow passage of current through them without undergoing chemical change. It is called electronic conductor. It is also called metallic conductor. Simply, these substances which allow the electricity to passes through them. These substances which allow passage of current through them without undergoing chemical change. Any chemical change. It is called electronic conductor. Example for electronic conductors here: metals, metals like silver, aluminum, mercury. Non-metals like carbon black, graphite. Some organic polymers like polyaniline, polypyrrole, polythiophene, polyacetylene, etc. when exposed to vapor of iodine. Polyaniline, polypyrrole, polythiophene, polyacetylene exposed with iodine vapors. And finally, last example, some salts like cadmium sulfide, copper sulfides. The electronic conductance of cadmium sulfide and copper sulfide is due to the crystal defect or interstitial defect. Due to crystal defect. Okay, this is the information about what is the electronic conductor. It is also called metallic conductor. Simply, it is a metal which is connected to the battery, which allow electric current through them without any chemical change. These substances which allow the passage of electricity to pass through them without undergoing any chemical change is called electronic conductor or metallic conductor. Examples here: metals like silver, aluminum, gold, copper, not gold here, silver, aluminum, copper. Non-metals like carbon black and graphite, organic polymers like polyacetylene, aniline, ferrol, polythiophene. Salts like cadmium sulfide, copper sulfide are due to the interstitial defect or crystal defect. Which is an example for salts. Next, some metals and alloys. Metals and alloys, they alloys at very low temperature. It behave like superconductors. Some metals, superconductors. What is superconductors? Some metals and their alloys. Their alloys which can behave at low temperatures, at very low temperature, very low temperature, that is 0 to 15 Kelvin. It shows some electricity. Example, ceramic materials are and mixed oxides also show superconductivity at temperature 150 Kelvin. Ceramic materials and their oxides. Okay, the ability of certain materials to conduct electric current. The ability of certain materials to conduct electric current with practically zero resistance. Practically zero resistance is called superconductivity. This is first time observed in H.K. Onus and H.K. Onus. He is a scientist 1911. He is a Dutch physicist. H.K. Onus in 1911, a Dutch physicist. The ability of certain materials or metals to conduct electric current with practically zero resistance. Practically zero resistance is called superconductivity. Example for superconductivity: lead, mercury, alloys. Examples here: mercury, lead, some mixtures like niobium and titanium, germanium, niobium, organic materials like fullerene, carbon nanotubes. Ceramic material is used as a making a superconductor or a class of materials are called perovskites. Next, what are the factors depends on the electronic conductor or metallic conductor? There are some factors are there. That is it depends upon nature and structure of metal. Second one, the number of valence electrons per atom. Number of valence electrons per atom. And third one is temperature. Means temperature decreases with increasing temperature. It decreases with increasing temperature. These are the factors depends on electronic conductor and metallic conductor. Thank you. Now, second type of conductors, electrolytic conductor. It is also called ionic conductor. Okay, some substances are the substances which have allow the passage of electric current. Through them with chemical decomposition takes place by undergoing chemical decomposition are called electrolytic decomposition. Here it is also called electrolyte. The conductance of electrolytic conductors due to flow of or movement of ion. The conductance of electrolytic conductors due to the conductance of electrolytic conductors due to flow of ions towards oppositely charged electrode. The movement of ions towards oppositely charged electrode. Example for electrolytic conductors: acids, bases, salts. In their aqueous or molten state. Salts in either molten or aqueous form. It is depends upon nature of electrolyte is added. And second one is size of the ions produced and their solvation. Size of the ions produced and their solvation means here ions surrounded by solvent molecules. The nature of solvent and their viscosity. The nature of solvent and their viscosity. Concentration of the solution. Fourth one is concentration of the solution, and finally fifth one is temperature. Okay, temperature increases with increasing temperature. It increases with increasing temperature. Okay, these are the factors depends upon. Simply, what are the differences between a metallic conductor and ionic conductor, sir? Electric current flows by movement of electrons in electronic conductors, just movement of electrons. And electrolytic conductor, electric current flows by movement of ions. In electronic conductors, the movement of electrons only. The electric current flow by movement of electrons in electronic conductor. Here, in electrolytic conductor, the movement of ions only. In metallic conductor, there is no chemical change occur, but electrolytic conductors, ions are oxidized and reduced at electrode. In metallic conductor, it does not involve the transfer of any matter, but in electrolytic conductor, matter is transposed. That means it involves transfer of matter in the form of ions. Okay, here metallic conductors, Ohm's law is followed. Here also both Ohm's law followed. Resistance increases with increasing temperature in metallic conductor. Resistance decreases with increasing temperature. Metallic conductor does not obey Faraday's laws, and electrolytic conductors which can obey Faraday's law. Okay, these are the differences between metallic and electronic conductor. Thank you.